At A, draw a tangent to the circle and produce OB to cut the tangent at C. Now, BN is drawn perpendicular to BD. BD is drawn perpendicular to OA. Area of a sector AOB is equal to, this is derived expression of R square x. Limit x tends to 0, sin x by x is 1. A plus sin 0 0, cos 0 is 1 divided by B. That's equal to A plus 1 divided by x. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important theorem. In the previous class we have discussed the important theorem number 1. Today I am going to discuss regarding very important theorem, that is theorem number 2. Theorem number 2, limit theta tends to 0 of sin theta by theta is equal to 1 where theta is in radians, that is sandwich theorem. So, or we can also use, instead of theta, limit x tends to 0 of sin x divided by x where x is in radians. This is very important theorem for the point of examination. Now move on to this theorem number 1. Let f and g be the two real valued function. Let us consider two real valued function f and g. Let f and g are two real valued function with the same domain such that f of x is less than or equal to g of x for all x in the domain of the definition. Now let us consider two functions f and g with the two real valued functions in the same domain such that f of x is less than or equal to g of x for all x in the domain of the definition for some a if both the limit, that is limit extends to a of f of x and limit extends to a of g of x exists. That is, if both the limit exists for x is equal to a, for some a, limit extends to a of f of x and limit extends to a of g of x exist. That means if both the limits exist, then f of x, therefore in theorem number 1, limit extends to a of f of x is less than or equal to limit extends to a of g of x. Now what is theorem number 2? That is called the sandwich theorem. So let f and g, f, g and h be the real functions such that f of x is less than or equal to g of x which is less than or equal to h of x. Suppose if there are three functions, let f, g and h be the real functions such that f of x is less than or equal to g of x which is less than or equal to h of x for all x in common domain of the definition, then real value of a, that is limit extends to a of f of x is equal to L, that is also equal to limit extends to a of h of x, that is the value of limit extends to a of f of x is equal to L, that is also equal to limit extends to a of h of x, then limit extends to a of g of x is also equal to L. That is, this theorem is called as the sandwich theorem. That means limit extends to a of f of x is equal to limit extends to a of h of x is equal to L, then the limit of this g of x, limit of this extends to a of g of x is also equal to 1, that's equal to L, that's also equal to L. This is called the sandwich theorem. So using this theorem we are going to derive very important theorem, prove geometrically that limit extends to 0 sin x by x is equal to 1 where x is measured in radians. Very important theorem. Now move on to the proof. Now consider a circle with O as center. Consider a circle with O as center and R is the radius, with O as center and R is the radius. Mark the point A and B on the circle. Mark the points A and B. Mark the points A and B on the circle such that angle AOB is equal to x radians. So consider a circle with O as center and R is the radius. Mark the points A and B on the circle such that angle AOB is equal to x radians. Now join OA and OB. So angle AOB is equal to x radians, right? So here OA is equal to the radius, OB is also equal to radius. This is equal to R, right? Now join AB. AB is a joint. Now at A At A, draw a tangent. Draw a tangent to the circle at A. A tangent is drawn to the circle. So AC is the tangent. A tangent is drawn to the circle at A. OB, produce OB. OB is produced to cut the tangent at C. To cut the tangent at C. Now, then, see here, at A, draw a tangent to the circle and produce OB to cut the tangent at C. Now, BN is drawn perpendicular to BD. BD is drawn perpendicular to OA. BD is drawn perpendicular to OA. This is the construction part. Let me explain once again. Very simple. Consider a circle with O center and R is the radius. Mark the points A and B on the circle such that angle AOB is equal to x radians less than pi by 2. Now, join OA, OB and AB. A tangent is drawn to the circle at A. A tangent is drawn to the circle at A and produce OB to cut this tangent at C. AC is the tangent. Produce OB to cut the tangent at C. Now, BN is drawn BD. BD is drawn perpendicular to OA. BD is drawn perpendicular to OA. This is the construction part. Now, if you observe carefully from figure, so find out the area of a triangle AOB, then the sector AOB, sector AOB, area of this sector AOB, okay. Then area of the big triangle AOC. So, if you observe carefully, the area of triangle AOB is less than the area of sector AOB, which is less than the area of the triangle AOC. That's it. From this figure, area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOC. Let us represent this as equation number 1. So, area of triangle AOB is less than area of sector AOB, which is less than area of triangle AOC. Now, first find out area of triangle. Area of a triangle AOB. What is the formula for area of triangle? Half into base into height. Half into, for this triangle, what is the base? Base is OA and height is equal to BD, right? OA into BD. Since you know what is OA, since you know OA is equal to R, that is also equal to OB. OB and OA are radius. Now find out BD. Now from triangle, just take this triangle, from this triangle. Now find out sin x. So from triangle sin x, that is from triangle ODB. Sin x is equal to, what is sin theta? Opposite by hypotenuse. What is opposite here? Opposite is BD divided by hypotenuse is OB. Now cross multiply it. If we cross multiply, OB sin x is equal to BD. So therefore BD is equal to, what is OB? Since OB is equal to the radius, R into sin x. Substitute here. So this becomes half into R sin x. So that's equal to half into R square sin x. So area of triangle AOB is half R square sin x. Now similarly, area of the sector, you know the area of sector. Area of a sector AOB is equal to, this is derived expression of R square x. Area of the sector is of R square x, right? Now find out the area of big triangle, that is area of triangle AOC. Area of triangle AOC is again half into base into height, half into base is OA. Here height is equal to AC. Now since from triangle AOC, find out tan theta. What is tan theta? Opposite by adjacent. That means here tan x. Tan x is equal to, what is opposite? Opposite is AC divided by adjacent is OA. Now cross multiply, if you cross multiply, OA tan x is equal to AC. So therefore AC is equal to, since you know what is OA, OA is equal to the radius R into tan x. So substitute here, half into OA is radius, AC is equal to R tan x. So this is equal to half R square tan x. Right. So what we got? Area of triangle AOB is half R square sin x. Area of sector AOB is half R square x, and area of the big triangle is half R square tan x. Now from equation 1 becomes, from 1. What is 1? Area of triangle AOB, that is half R square sin x, is less than area of sector AOB, that is half R square x, which is less than area of the triangle AOC, that is half R square tan x. So half R square sin x is less than half R square x, which is less than half R square tan x. Now what is the common? Common factor is half R square. Divide by half R square. What you will get? Sin x less than x less than. Now this can be written as sin x less than x less than. Tan x can be written as sin x by cos x. Now just divide by sin x. Divide by sin x. If you divide sin x, 1 less than or equal to x by sin x, which is less than or equal to sin gets cancelled, 1 by cos x. Now reciprocate it. Reciprocating. So there is one formula. If A is less than B implies 1 over A is greater than 1 over B. So then this becomes, that is 1 is greater than x by sin x becomes sin x by x, which is greater than cos x by 1 is cos x. Now when x tends to 0, what happens? Cos x tends to cos 0. Cos 0 is nothing but 1. So sin 0 0, cos 0 is equal to 1. That means here, that is 1 greater than sin x by x, which is greater than 1 when x tends to 0. So that means the value of sin x by x lies between 1 and 1 when x tends to 0. That is called your sandwich theorem. So therefore this can be written as, so the final conclusion is, therefore limit x tends to 0 of sin x divided by x is equal to 1, where x is in radians. So when x tends to 0, the value of sin x by x lies between 1 and 1. So therefore when x tends to 0, sin x by x is also equal to 1. That is called your sandwich theorem. So hope you followed. The value of sin x by x when x tends to 0 is equal to 1 is called our sandwich theorem. Right. Very important for the point of examination. Right. So here the value of sin x by x lies between 1 and 1 when x tends to 0. Therefore the value of sin x by x is equal to 1. That is denoted as limit x tends to 0, sin x by x is equal to 1. That is called our sandwich theorem. Very important. Just find out the area of the triangle AOB and the area of the sector AOB and the area of the greater triangle, the big triangle AOC. Substitute in equation number 1. So you will get half R square sin x less than half R square x, which is less than half R square tan x. Divide by half R square, you will get sin x less than tan x. Now sin x less than tan x can be written as sin x by cos x. Divide by sin x, 1 x by sin x, sin gets cancelled, 1 by cos x, reciprocate it. So this becomes 1 is greater than sin x by x, which is greater than cos x by 1 is cos x. When x is equal to 0, the sin x by x lies between 1 and 1. Therefore, the value of sin x by x is also equal to 1 when x tends to 0 is denoted as limit x tends to 0 of sin x by x is equal to 1. That's it. Hope you followed. Now, this is very important theorem. You may expect for 6 marks or 5 marks. Now, move on to the problems based on this. Now, let us evaluate some problems. So, limit x tends to 0 of sin ax by bx. So, here this can be written as limit x tends to 0 of sin ax divided by just divided by bx. So what is given? Limit x tends to 0 of sin ax by bx. Divide both numerator and denominator by x. If we divide by x, limit x tends to 0 of sin ax divided by x whole divided by bx by x. So this x and x gets cancelled. Apply the limit for both numerator and denominator. Limit x tends to 0 of sin ax by x whole divided by what is left is b. So here convert this into sin theta by theta form. Just multiply and divide by a. This is equal to a into this sin ax by ax is equal to 1 by b, that's equal to a by b. Simple for 1 mark. Okay. Now move on to the next problem. So limit x tends to 0 of cos x divided by pi minus x. Now this is very simple. Put x is equal to 0. What happens? This is cos 0 divided by pi minus 0. Sin 0 0, cos 0 is 1, since cos 0 is equal to 1 divided by pi minus 0 is 1. So the answer is 1 by pi. That's it. Limit x tends to 0 of 1 minus cos x by x. Now here what is given? Limit x tends to 0 of 1 minus cos x divided by x. For this, just rationalize the numerator. Multiply and divide by 1 plus cos x by 1 plus cos x. So this can be written as limit x tends to 0 1 minus cos square x divided by x into 1 plus cos x. So 1 into 1 is 1, minus into plus minus, cos into cos is cos square. So this is limit x tends to 0. 1 minus cos square is sin square x divided by x into 1 plus cos x. So this can be written as limit x tends to 0 sin square x, that is sin square x, that is sin x divided by x into 1 sin x divided by 1 plus cos x. Now apply the limit for this. You know sin x by x is equal to 1 into sin 0 is 0 divided by 1 plus cos 0 is 1. 1 into 0 by number is 0, that's equal to 0. So the answer is 0 for this. Okay. Or you can also use off angle formula. 1 minus cos x is equal to 2 sin square x by 2. Using that you can simplify. Now move on to the next problem. Now limit x tends to 0 of ax plus x cos x divided by b sin x. Now very simple, just divide by x both in numerator and denominator, then this becomes limit x tends to 0 of term by term division. X gets cancelled, a, again x gets cancelled, cos x divided by, in the denominator, b as it is, sin x by x. Now just apply the limit. So if you put x is equal to 0, a plus cos 0 divided by b into this. Limit x tends to 0 of sin x by x is 1. A plus sin 0 0, cos 0 is 1 divided by b, that's equal to a plus 1 divided by b. That's it. Okay. Now move on to the next problem. So 1 minus cos x divided by sin square x. Very simple problem. This can be written as limit x tends to 0 of 1 minus cos x as it is divided by, in the denominator, sin square can be written as 1 minus cos square. So this is equal to limit x tends to 0 1 minus cos x as it is. So 1 minus cos square can be written as 1 plus cos x into 1 minus cos x. So cancel the terms. 1 minus cos gets cancelled. Limit x tends to 0 1 by 1 plus cos x. Now put x is equal to 0. That is 1 divided by 1 plus cos 0. What is cos 0? Sin 0 0, cos 0 is 1. 1 plus 1 is 2. 1 by 2 is the answer. That's it. Okay. Move on to the next problem. X tends to 0 of cosecant x minus cot x. So this can be written as limit x tends to 0. Cosecant x is 1 by sin x minus cot x is nothing but cos x divided by sin x. Take LCM. So limit x tends to 0 of sin x is the LCM. Sin gets cancelled. In the numerator we will get 1 minus cos x. So again this is nothing but same, rationalize the numerator. Multiply and divide by, or you can use off angle formula. Let me use off angle formula. 1 minus cos x is also equal to 2 sin square x by 2. In the denominator for sin x, 2 sin x by 2 into cos x by 2. 2 gets cancelled, 1 sin gets cancelled. Limit x tends to 0. Sin x by 2 divided by cos x by 2 is tan x by 2. Now apply the limit for this. Tan 0. Tan 0 is equal to 0. That's all. Okay. Or you can also simplify using same method. Rationalizing this. This is how we are going to solve this problem. So the answer for this is 0. That's it. Okay. So hope you followed. These are few problems based on the theorem number 2, that is sandwich theorem. That's all regarding today's session. Let us meet with the different types of problems in the next session. Thank you. Thank you very much.